Hi, quick little video here to take some of the mist out of using the NanoVNA to measure SWR at the feed point of your amateur radio transceiver or tuner. Okay, so let's simplify, but before we do that, you might want to sync up with the version I'm using. So to do that, let's go into the menu. The main menu, hit Config, and then click Version. Okay, having done that, we'll go back and let's simplify. So first of all, go into Trace and get rid of all but one of the traces. So let's go ahead and uncheck the blue trace, select and uncheck the green trace. Whoops. Select and uncheck the purple trace. Now we just have yellow. However, channel 0 S11 is mapped to delay 1 nanosecond, so let's go back, click Format, and select SWR. And you can see it's reflected the changes. Okay, the next thing we want to do is go back again, and go into Stimulus, and set our start and stop frequencies. So the range we want for this will be 7 megahertz, I believe we already had. And then click stop. And for this, we're going to try 8 megahertz. Now note that the changes are reflected at the bottom of the NanoVNA. We have a start frequency of 7 megahertz and a stop of 8. So the next thing we're going to want to do is calibrate. And we want to calibrate, when we do that, we want to do so as close as possible to the device under test. Here I have a jumper. It's about a 12-inch jumper terminated in a male SMA, which I've attached a barrel connector, bullet. And here are the 3 slugs that come with the VNA for calibration. The first calibration slug is open circuit. The next one here is closed, or we click calibrate, we have short. This is the shorted condition. So we have open, short, and load, which is a 50 ohm load, simulating what we find in most proper antenna systems. So coming back to the VNA, we want to attach first our open circuit slug to the end of the cable. And having done that, we click open. And we've calibrated the open circuit condition. Next, we attach the shorted slug. Again, this one. Tighten that up, finger tight, and we run the next test. Click short. And finally, we place the 50 ohm load on our SMA barrel connector, tighten it, and run the final test for the calibration we need. Okay, so we won't be needing isolation or through, so we can now click done. So normally we would save this. I'm going to just go back and not save, and back again. All right, so we're ready to run the test. Okay, so now we have the VNA attached to the device under test, which is my 40-meter dipole, resonant and being fed by ladder line, as seen through my Polestar tuner. So the test point is right here, and there's an additional jumper. I'm not too worried about, at this frequency, any inductance or capacitance or delay added. It will be insignificant. The last band I was working was 30 meters, and I'm tuned up approximately there. So let's watch the VNA as I change the inductor and capacitor values. My dipole is usually happy on 40 meters at around 250. Oh, we can see the trace starting to appear, and if we figure out which direction we need to go with the capacitor, we've already got a null. So I'll show you how you can instantly find out where you're tuned up. Go into the menu and hit search maximum. Hit it again until you see your marker. Go out of the menu. So we've got a null 1.036, almost flat SWR at our frequency here, and if we jog the VNA, we see M1 is at about 70-50, 70-60 megahertz on the 40 meter band in the CW portion of the band. Flat SWR.